It's one thing to have a GNS3 topology that includes a router and an ASA, and it's another thing to actually get it functioning and working. So what you and I get to do in this nugget, my friend, is take the topology that we built together in the nugget called build an ASA GNS3 topology, and we're going to add configuration to it to get basic connectivity between the router and the ASA, as well as give the ASA connectivity out to the live internet. Now that I think back on it, in our video called ASA Concepts, we learned about the basics of how the ASA works and how it thinks with its security levels and IP addresses and so forth. And then in the ASA GNS3 integration nugget, we talked about how we can add an ASA as part of GNS3. And in the nugget titled Build an ASA GNS3 Topology, we actually put that ASA inside of a topology with other devices inside of GNS3. But the challenge is this: we have not yet really configured that ASA. And so in this nugget, we're going to take the basic topology that we built in Build an ASA GNS3 Topology in that nugget, and we're going to start to configure it. And here are some of the cool things we're going to do. On this ASA, we're going to configure IP addresses. So on this interface here, we'll name it the inside interface. We'll give it the IP address 10.1.0.250. On this interface, which is the 0 interface, gigabit 0, we'll call it the outside. We'll give it the IP address of 192.168.1.250 on that interface. And then we'll have R2 represent, in my home lab anyway, the device that's doing PAT and further routing out to the internet. And the default gateway on this router R2, which is already in place on my home network, is .1. Also here on R1, we need to configure it with a couple of IP addresses. So we'll give it the 10.1.0.1 address on its fast Ethernet 00 interface, and we'll give it the IP address of 10.0.0.0. So this is the 10.0 subnet, this is the 10.1 subnet. So on this left-hand side, 0/1 will be 10.0.0.1. And the security levels for these two interfaces, the inside is going to be 100, and the outside is going to be a security level of 0. We'll also need to set up some routing. So on this ASA, we'll tell it that its default route is going to be using .1, which is the router that leads to the internet. And we'll also tell the ASA that because it's not directly connected to the 10.0 subnet, we can set up a route that says to get to 10 anything, the next hop is going to be 10.1.0.1, which is R1's address. And because R1 is directly connected to this network, he will know how to reach that network. Also on R1, we'll set a default route that says to get anywhere that you don't know how to get to, go ahead and use the default route of 10.1.0.250. And you may think, well, Keith, how come we're focusing so much on routing and other aspects in this firewall lab in GNS3? And the answer is, my friend, we want it to work. And I wanted to make sure that you and I in this course went through all the details so that you can have success in setting up any part of this you want to for practice and reinforcement in your own lab environment. And that's why I'm including all the aspects that I'm doing, so there's no mystery on exactly how you can replicate this and have a practice environment for yourself. And the last thing I'd love to do is take a look at preparing for ASDM. ASDM is the graphical user interface that we're going to use to manage an ASA. And just because this is in a lab environment doesn't mean that we can't use the Adaptive Security Device Manager, ASDM. So to do that, what we can do is we can take the ASDM image and copy it over to the flash of our ASA in GNS3. And that way, from a PC, for example, I've got a PC sitting right off this network here at 192.168.1. I'll put a question mark there because it's a DHCP assigned address at the moment. And this is my management computer. So to get the ASDM software on this image of the ASA, first, I'll have the image here. So I'll have the ASDM image sitting on this computer. I'll set up a really simple TFTP server because somehow we need to get the image for the ASDM over to the flash of the ASA. So there's lots of TFTP servers that are free out there. For example, SolarWinds has one, and there's a plethora of other ones. So whatever TFTP server you want to use, we're just going to set up a simple TFTP server on this management computer and then copy the ASDM image over to flash. And that'll be part of the preparation and setup so that we can use ASDM if we want to manage this ASA. I'm going to walk you through each of these steps. And check this out. I've also got another document for you. It's called the Basic ASA Lab Bootstrap Commands. And it has all of the commands that we're about to use on the router and the ASA to go ahead and get everything in this topology working. So not only will you have the nuggets that you can refer to and go through step by step, but you'll also have a document as part of the Nugget Lab files that you can have. And you can use them as a checklist, for example, as you go through each of the steps if you want to. And if you're using different IP addresses in your topology, just swap out the IP addresses I'm using for the IP addresses that you want to use in your own lab environment. So here in GNS3, I'm going to click on Open a Project, and we're going to grab our CCNA Security Initial Topology.gns3. That's the project we created in the Nugget called Build an ASA GNS3 Topology. And let me put the labels on just to make sure I have the right interfaces involved. So I just want to make sure it matched up with what we had in the previous diagram. It looks good. And I'm going to go ahead and power this topology on by clicking on the Start icon to start all the devices in this topology. I'm also going to go ahead and click on the console icon, which is going to open consoles to all devices, which is going to include our PC1, which is our virtual PC simulator, R1, and the adaptive security appliance. So we'll have 3 windows open. So let's begin on the ASA. I did a little bit of pre-work, and I wanted to make sure that I didn't do something behind the scenes that you didn't see. So I'm going to do a clear config all, which basically wipes out the entire configuration on the ASA. And that would not be a great one to do in a production environment on live gear because it immediately wipes out the entire config. But for our lab environment, it verifies that you and I can see every single step that we're going to implement. So we're already in configuration mode. Let's go to interface gig 0. And in interface gig 0, let's set the security level to a 0. That's the outside interface. Let's give it a name. We'll use the name if command, which is how you give an interface a name. We'll call it outside. I'm going to use lowercase. And we'll give the IP address of 192.168.1.250 with a 24-bit mask. So those are the basic settings: the security level, the name if, and also the IP address. By default, if you use any name other than inside, it's going to default to a security level of 0. And if you use the name inside for an interface, when you use the name if command, it's going to default to a security level of 100. But we can set it to any number between 0 and 100 inclusively that we want to. We're also going to do a no shutdown to make sure the interface comes up. Next, let's go to interface gig 1. That's our inside interface. So the security level there, we're going to set to 100. The name that we're going to give it with the name if command is going to be inside. We'll give it the IP address of 10.1.0.250 with a 24-bit mask. And we'll make sure it's up as well with a no shutdown. And then we'll exit out of interface configuration mode. So we've got gig 0 set up, we've got gig 1 set up. Next, let's take care of our routing. We want to make sure that this firewall, if it doesn't know where to forward a packet, has a default route. And the syntax for that is route. And then we're going to specify the interface it should use. So we want to route using the outside interface. So that's the actual name of the outside interface right there. Then the network we're trying to reach. I'm going to put in quad zeros for the network and mask, which is the default route. And then a space, and then the next hop that this ASA should use as its default route. And that next hop is 192.168.1.1, which is my router that currently exists on that 192.168.1 network, which is doing routing and PAT out to the internet. And we'll press enter. Another consideration is, what about reaching the 10.0 subnet? The ASA isn't directly connected to it, and it doesn't have a route to it. So we're going to add a route for that one as well. So we'll use the command route. And this time we want to route using the inside interface, which is gig 1. If we have a whole bunch of subnets of 10, we could just say 10.0.0.0, and then for the mask, just say 255.0.0.0, and that to the ASA simply means, okay, 10 anything. So if it doesn't have a more specific route in its routing table and it needs to forward to 10 anything, it can use the next hop that we're about to specify for that route. And that next hop would be 10.1.0.1, which is the fast Ethernet 0.0 interface over on R1. So we'd have connectivity. And we'll press enter. Now, for testing purposes, what we could do is we could try to ping from this ASA all the way out to a Google server at 8.8.8.8. That would imply that the default gateway is working and that my default gateway that goes to the internet is also doing PAT appropriately for the translation of his RFC 1918 address into one that's routable on the internet. So let's do a ping out to 8.8.8.8. Notice we don't have to leave configuration mode. It takes a ping and other show commands right here from configuration mode. We'll press enter, and 5 out of 5. That sounds almost too good to be true. Let's do a trace route just to verify that we are really going out through the internet. So we'll do a trace route to 8.8.8.8. Press enter, and sure enough, that's great. So we have full connectivity, or at least connectivity from this ASA out to a Google server at 8.8.8.8, which implies connectivity to the internet. So let's save our configuration. I'm going to do a copy run start, or the shortcut for that is WR, which is a shortcut for write mem, and press enter. So now that's saved. We would also periodically want to save our configurations in GNS3 so that the GNS3 project has all the latest and greatest information saved. Next, let's go to our router 1, and we need to do some basic configuration on it as well if we want it to be a good player in our GNS3 ASA topology. So we'll start off by going to interface fast Ethernet 0/1. That's the left interface that's going towards PC1. We'll give it an IP address. So we'll use the IP address of 10.0.0.1 based on our plan with a 24-bit mask. We'll make sure it's up with a no shutdown. And that looks great. Next, let's go over to interface FA 0/0. That's the interface that's facing towards the ASA from the router. We'll give it the IP address of 10.1.0.1 with a 24-bit mask. And we'll make sure it is up as well. Now, if you're getting messages, for example, like your interface just bounced, that's because the interface was previously down. Now, in my case, because I was doing some testing and so forth, I'm not getting a console message about the interface coming up with the no shutdown command, very likely because it was already up. So if I did this, shutdown, there's my console message about the turning of that interface. And if I did a couple up arrows and a no shutdown, then I would get another console message indicating that the interface had come back up with the link change notification. Just like that. Also, R1, if he needs to reach out to the internet, or that direction anyway, he needs a default route. So we'll do an IP route with the quad 0, which is the default route saying the next hop should be 10.1.0.250, which is the ASA. And we'll get out of configuration mode. We'll save our configuration with a WR, which is equivalent to a copy run start. And once again, we'd also want to click on the Save Project button as part of GNS3, so GNS3 can remember all the details as well. And just for grins, let's do a quick ping of 10.1.0.250 just to make sure that we can reach our default gateway, which is the ASA Gig 1 interface. And sure enough, we got 5 out of 5. That's fantastic. So let's do a quick check. We've implemented IP addresses on R1 and on the ASA, which is great. We have security levels and names set up for the interfaces on the ASA as well. We've set up routing for both R1 and the ASA. And our last step, at least in this nugget, is to make sure that we have the ASDM image sitting on the flash of our ASA so that if we want to, we can run ASDM. And I say if we want to a little bit with a chuckle because we are absolutely going to want to have that functionality so we can practice and use ASDM to manage in a graphical user interface our ASA. In multiple previous nuggets, I've talked about searching the internet for some pre-built packages that have a lot of the resources that we might need to implement a home lab. And one of those was a file called 210-260 homelabfiles.zip. And as part of that, I noticed that ASDM was one of those image files as part of that download. Another option would be for the latest and greatest version of ASDM is that if you had a Cisco Connection Online account up at cisco.com and you had a service contract in place, it's very likely your account could also download the ASDM image file that we could then copy over to the ASA. And one really convenient thing I've noticed about the home lab files that I've seen out on the internet is that there seems to be a few people sharing them in multiple locations, which is, you know what, that's very helpful for other people who want to study and practice and build home labs so they can build their skills with Cisco products, including the ASA and Cisco routers and ASDM and so forth. So what we're going to do is we're going to take the ASDM image file and I'm going to have it on a PC. This is my management PC. And on this management PC, I'm going to go ahead and set up a little TFTP server. And there, again, are lots of different TFTP servers out there, and most of them are free. I believe SolarWinds, which is a great company, has a free little TFTP server, and others do as well. So what we would do is just install whatever type of TFTP server software that you feel is safe on this management PC. It's going to ask you to point to a folder where it's going to share files, and you simply point to the folder that has the ASDM image file in it. So on this PC, I just checked. I did an IP config to verify what the IP address is here. It is 192.168.1.92. That's the IP address of this management PC. Also, if you're running a TFTP server and the ASA reaches out to copy that from that TFTP server on this PC, if you have firewalls in place, either Microsoft or other third-party firewalls, it is very possible that those firewalls are saying, I'm not allowing any inbound connections. No way, no way. So let's keep that consciously in mind if we have to do any troubleshooting of why a TFTP download from this machine running the TFTP server software isn't working correctly. We could also do some basic checks, for example, with pings to verify that this PC can reach this IP address of the ASA, and they're on the same directly connected network. So hopefully this PC should be able to ping. Now here's what some people do, is they'll try to ping from the ASA to the PC, and it's very likely, once again, that you have a firewall in place on the PC that says, hey, I'm not allowing inbound connections, including a ICMP echo request. So I would say one of our first tests would be from this PC, where we're running the TFTP server. I would do a quick ping of the ASA, who by default will respond to a ping request, just to verify that we have basic connectivity, and then we'll try the copy from the TFTP server down to the ASA. So my TFTP server of choice is a really old one. I don't know if this is the best, and I'm not recommending it. I'm just saying this is what I'm using. It's called 3CD, 3Com Daemon. That was a company that was very, very popular a few decades ago. In any event, I've got the TFTP server software configured. It's currently running on the system. It's currently listening on port 69, which is the well-known port for TFTP. And it's listening on all these IP addresses, and that's because I have multiple adapters, logical and or physical, in this device. So anyway, there's .192. We're listening on port 69. I've also configured my TFTP server to point locally to the directory, to the folder where the ASDM image file is. To verify that, we'll click on Configure TFTP Server, and this is specifying where it's pointing to. So what I could also do is go to that folder and just verify that the file exists. So I'm going to click on Cancel there, and here is the actual folder. So there's the 210.260 home lab files.zip. It was extracted, and among other things, it has the ASDM-751.bin file, and that is the file that I want to go ahead using TFTP and copy that from my TFTP server over to the flash on the ASA that's in our GNS3 topology. Now, ideally, from my management computer, which is acting as the TFTP server, I want to verify that I can ping that interface on the ASA. So I'll ping 192.168.1.250. And we've got 4 replies from 4 requests. That's great. That just verifies basic connectivity. Next, let's go over to the ASA and copy, or attempt to copy, the ASDM image file from the TFTP server over to the flash of the ASA, because that's where it needs to be. So at the ASA, we're going to do a copy TFTP : flash : and now if you just do it like this, which is not a bad idea, it's going to prompt us for the details. For example, where you're copying from, what's the file name, and those kinds of things. So let's press enter. Now it's asking us for the name of the remote host, which is the TFTP server at 192.168.1.92. That's the correct address. That's what we just looked at a moment ago in the 3Com daemon. The source file name is ASDM-751. If you're using a slightly different version, go ahead and put the correct name in, the one that you want to put on the flash, and that is a .bin. We'll press enter, and it's asking for the destination file name on the flash, and I'm going to call it the same name. So we'll go ahead and simply press enter to accept the name that's in brackets, and that's a very, very good sign. So it's copying it over the network. It's going to copy it to flash, and when it's done, we'll have an image of ASDM-751.bin sitting on the flash of the ASA. So this process may take, I don't know, somewhere between 2 and 10 minutes, depending on how fast your computers are and the connections involved are. So I'm going to go ahead and, through the magic of editing, we'll return here when the copy is complete and that file, that ASDM image file, is sitting on the flash of the ASA. All right, that is complete. It took a matter of 209 seconds for that to complete. Fantastic. I'm also going to change the host name. So we'll use the host name command and call this guy ASA-1, press enter, and then we'll save our configuration. I also want to go back to our router real quick and make sure our configuration is saved there on R1. And then I'm going to go up to our GNS3, and in GNS3, I'm going to click on Save Project right here just to make sure everything is saved. In this nugget, we've taken a look at the actual configuration steps in our GNS3/ASA lab environment to get the router and the ASA bootstrapped and configured and mostly functional. And the commands that we used at the command line for the router and the ASA I've included as part of the Nugget Lab files. The file is called basic ASA lab bootstrap commands.txt. And again, those are available as part of the Nugget Lab files available with this course. So I look forward to talking with you in the next nugget as we get to put ASDM to work and start using it in our GNS3 lab environment. Until then, I hope this has been informative for you, and I'd like to thank you for viewing.